Welcome to all of you. Now we discuss few question paper on SageMath year 2022 or semester 4 mathematics honors paper ACC B2. This is the question paper. Question 1A. The output of square root of 144 and square root 8 are correct option 3, 12 and 2 star square root 2. Here question 1A, correct option is A, square root of 144 and output is equal to 12, and B is the square root of 8, output is 2 star square root 2. Next question 1B, what will be the output of the following sage code? Log square root 100 to the power 3, 10. Correct option is 3. Here A equal to log square root 100 to the power 3, 10, and print A, output is 3. Output is 3. Next question 1C. Output of 19 by 2 minus 19 double slash 2 plus 19 modulo division 2 in sage code is, correct option is 3. Answer is 3 by 2. A equal to this 19 by 2 minus 19 double slash 2. This is the quotient division. 19 divided by 2 and quotient, and 19 modulo division 2 gives the remainder division. So we get the result 3 by 2 for this. Actually, (19 by 2 minus 19 double slash 2, so 2, 9, 18, so 9 is the quotient. Division by 2, 19 is divided by 2 is quotient is 9 plus 19 modulo division 2 gives the remainder. So here remainder is 1. So 1, so this equals to 19 by 2 minus 8. So this equals to 19 by 2, 19, 8, 16, 16, 3 by 2. Correct answer is 3 by 2. So this is the answer. Question D. What happens when single quote 2 equals 2 is executed? Answer is 1, false. Because single quote, within single quote 2 gives the character string, and the right hand side 2 is an integer. So left hand side is a character in string form and right hand side is integer. So this equality, check this equality. So this is false. To student, this is the string and this integer. So this is false. Tell this false. Question E. What will be the output of the following sage code for I in range 2.0 colon condition print I? This output is 3, answer is 3, and error will occur because this question is the wrong question. So for this, this is the wrong question for this. So actually correct answer, correct option of this question is this question E. This is the wrong question. So for I in the range 2, here 2.0 is wrong. So it is 2, and this 2, for this 2 I runs from 0 less than equal to I, initial value of I is 0, and I is less than 2, up to 2, here the step is 1. So print I gives first 0 and then next I equal to 1. So, but here 2.0 gives an error will occur. Next question, F. Which of the following is the correct code for computing all divisors of 24? Here correct option is 1, because here the divisors is 24, divisors 24. Here the question F, correct option is 1. Here A equal to divisors 24 gives the output is 1, 2, 3, 4, 6, 8 and 12 and 24. But other options are wrong. Next question G. What will be the output of the following sage code? Fx equals to 3x plus 5, gx equal to x cubed plus 1, hx equals to f of gx, print hx, print h1. And this question is also wrong question. So this is wrong question here, because here print hx, this hx is within parenthesis, and print h1 is also this h1 is also within parenthesis. So correct answer is this print hx, which gives the 3x cube plus 8, and print h1 gives the output 11. Here f of g gives 3 star g is x cube plus 1, so 3 x cube plus 1 plus 5, and we get this. Next question, to evaluate square root of minus 4, correct answer is 2, square root minus 4 comma all equal to true. This is the question H. Here option 2 is the a square root minus 4 all equal to true, and gives the output this 2 star I 2i minus 2i. Here I is the complex number, square root minus 1. Other options are wrong. Question I. Which of the following sage command is not correct? Is not correct to get the derivative of get the derivative of sine x square. Not correct. So correct answer is 3, is the gx equals to sine x square g dot derivative 2. G dot derivative 2 gives the second order differentiation of the function fx sine x square. Otherwise, the option 1, option 2 and option 4 gives the first order derivative. So they are all correct. Option 1, option 2 and option 4 are correct here, and so our correct answer question I. Correct answer, correct option is 3. This is the not correct for the first order derivative, because here 3 gives the second order derivative of fx here sine x square. Question J. Which one of the following sage codes is correct? Here correct answer is 1. Here correct answer is 1. Here if a greater than b colon indentation print a, else colon indentation print b. Correct answer is 7. But here option 2 is not correct, because after if, in the line of if there is no colon, and in the line else there is no colon, and answer 3, option 3 is also not correct, because here else is within the indentation if loop, including if loop. So this is wrong, and this equal to 5 if print a, this a is not within the parenthesis, and this print b is not within the parenthesis, so this is also wrong. Next question 2, section 1. Question 2, section 1. Question 2, give an example to show Sage can be used as calculator. It is obvious, you can add any integers, subtract or multiply 5 plus 2 minus 2 plus 5, and the output is simply 3. So we can use SageMath as calculator. Question 2b. What will be the output of the following Sage code? State the digit. R equal to 30, area pi star r square, print area. Here pi is in symbol, So this is the wrong question. Actually, pi in a small letter is the actual correct answer. So r equal to 30, area pi star r square, print area. So correct output is 900 pi, the correct answer. But here question is this, pi is the wrong answer. Question 2c. Write the Sage command to calculate the expression 500 1 minus bracket 1 plus 0.5 to the power minus 30 whole divided by 0.05. Correct answer is this. Output comment is the comment 500 start with first bracket start 1 minus first bracket start 1 plus 0.05 first bracket goes to the power first bracket within first bracket minus 30 first bracket close division 0.05 is the correct option, correct code for sage command. Next question 3a. Write sage command to evaluate the following expression. Value of e to the power 20, e to the power 1 by 20, 20 to the power 1 by e in 20 decimal places. And second part, the absolute numerical value of the pi by 22 by 7 minus 1 in 50 decimal places. And third part of this question is the value of square root of 3 plus square root of 3 plus square root of 3 plus 1 by 3 in 10 digits. So question 3, question 2D, write a built-in sage command to find the common logarithm of square root of 100 cube. Justify that the sage will give the exact answer. Here, question 2D, as log square root 100 to the power 3, comma 10. Here, comma 10, actually, this gives the common logarithm. And that actually, this gives the base 10. Logarithm with base 10 is the common logarithm. So, correct answer is 3. Output is 3. And the justification is this, square root 100 to the power 3, this actually is square root of 10 to the power 6. So, 10 to the power 6. So, square root 10 to the power 6, and this equals to 10 to the power 6 square root of 10 to the power 6 1 2 3 4 5 6. So this square root of 10 to the power 6 is what is square root of 10 to the power 6, and this gives 10 to the power 10 to the power 3 10 to the power 3. So log to the base 10 10 to the power 3, this equals to 3. This equals to 3. Log to the base 10 to the power 10 to the power 3 10 to the power 3 comma 10 to the base 10, and so this gives 3. Next question 3. Question 3, 3a, first part is this, value of e to the power 20 plus a value of e to the power 1 by 20 plus 20 to the power 1 by e 20 decimal places. So e to the power 1 by 20 1.0 by 20.0 plus 20 to the power 1 by e dot in digits numerical approximation digits equal to 20 decimal places. So print a. So correct answer is a is this 20 decimal places. Here 1 2 3 4 5 6 7 8 9 10 12 13 14 15 16 17 18 19 1 2 3 4 5 6 20 decimal places. And next question, the absolute numerical value of pi by 27 minus 1 in 50 decimal places. So this a equal to absolute pi by 22 by 7 minus 1 dot in digits 50. So here the digits 50 decimal places, digits 50. So if you put in place 50, we put 5. So run this. So here 5, 1, 2, 3, 4, 5. Digits 5, not decimal places here. Digit 5. Digit 5, 1, 2, 3, 4, 5, 6, 7, 8. 8 decimal places. Digits 5, not decimal places here. So digit 5, here digit 5. In the question is this decimal places. Decimal places. Here decimal places. And question B equal to, if you put at 20.0 in real mode, float mode, by 7.0 minus 1 dot absolute of this, and then you get the absolute value of this. C is the numerical approximation of this digit 50, digits 50. So this you get this result, this. So here in this given question, here pi by 22 by 7. So obviously you choose the first sage code, yes, 22 by 7. And third part of this question is this square root 3 plus square root 3 plus square root 3 plus 1 by 3 and in digits 10 and 10 digits this. So b is the value of b is 10 digits, but if you put here 1.0 by 3.0, you also get the same result. Question 3b, give the output of the following sage command: 27 to the power 1 by 3, comma 64 to the power 1 by 4, 2 to the power 10 to the power 1 by 3, 8 to the power 1 by 3, plus 16 to the power 1 by 4 dot n, numerical approximation. So question 3b, here first part 27 to the power 1 by 3. So print a answer is 3. Explanation is here, and b equal to 64 to the power 1 by 4. Answer is b is this 2 into 4 to the power 1 by 4. Actual answer is this. Explanation for this 64 is 2 to the power 6 to the power 1 by 4. That is 2 to the power 4 into 2 to the power 2 whole to the power 1 by 4. That is 2 to the power 4 into 1 by 4 plus 4 to the power 1 by 4. So this is equal to 2 to the power 1 and star 4 to the power 1 by 4. Next, third part, 2 to the power 10 to the power 1 by 3. So 2 to the power 10 to the power 1 by 3, correct answer for C is 8 into 2 to the power 1 by 3. And explanation is there, 2 to the power 10, we can write 2 to the power 9 star 2 to the power 1 whole to the power 1 by 3, and 2 to the power 9 into 1 by 3 into 2 to the power 1 by 3. So 2 to the power 3 into 2 to the power 1 by 3. So 2 to the power 3 is 8. So 8 into 2 to the power 1 by 3. And question D, option fourth part of this question, 8 to the power 1 by 3 plus 16 to the power 1 by 4 dot numerical approximation this function. So here output of D is this 4 point this 0 0 0 0. This explanation is this 8 means 2 cube whole to the power 1 by 3 plus 2 to the power 4 to the power 1 by 4, that is equal to 2 plus 2, that is equal to 4. 4 but here if we omit here numerical approximation operator in the previous line, and so we get the output is 4 only. Output is 4 only here. Next question, section 2, 4a. 4a, how can you plot functions with their asymptotes in Sage? Explain for the function f(x) equals to tan x for minus pi less than x less than pi. So question 4a is the code, Sage code, plot first bracket start tan x comma first bracket start minus pi comma pi first bracket close comma y mean equal to minus 10 comma y max equals to 10. So you get the asymptotes this point and this point, the two asymptotes here within range minus 10 to 10. And question B, plot the graph of fnx equal to sine to the power nx in Sage in the interval 0 to pi closed interval for n equal to 1, 2, 3, 4 use different colors and different plot styles for different graphs. So this is the question here. P is the plot sin x, comma 0 to pi within interval closed interval 0 to pi. So comma 0 comma pi comma color 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 equal to single quote within single quote violet color. Line style equal to within single quote dot colon comma legend underscore level equal to y sin x. So this is the y equal to sin x. By the legend level, uh, you get the output here within box in this graph. Within box, you get the here the right here y equal to sin x, and p1 is the plot of square x. Sine square x in the same range 0 to pi. Color green is this graph, and line style is dash. Line style is dash. Legend level y equal to sine square x. P2 is the plot sine cube x, and color is royal blue. Line style is dash dash. So this is the graph for sine cube x. Legend level is y sine cube x, and this the P3 is the plot sine to the power 4x. Color is magenta. So color is magenta here. Line style dot dash here P1 P2 P3. So here omit here plus P3. Run this graph. So here P3 is the sine to the power 4x, and this is the sine to the power 4x dot dash magenta color. This is the graph sine to the power 4x. Legend level equal to within single quote y equal to sine to the power 4x. Next question 5. Question 5. A. Write sage code to plot a 5-pedaled rosette r theta equal to 2 cos 5 theta 0 less than 2 pi. In the above plotting, which one is the input and which one is the output? Here variable t for theta within single quote variable t. Polar underscore plot is the predefined function in Sage Math. A polar equation to plot the polar curve. This polar underscore plot within first bracket this 2 cos 5 theta comma the range of theta t comma 0 comma 2 pi. Here given theta 0 less than theta less than 2 pi. So this 0 comma 2 pi, and this is the graph, beautiful graph here. Here input is the theta, that is t, and output is the r here. Next 5b. Question 5b, correct the following sage code plot sin t comma minus 10 comma 10. Question 5b. Here write in the first line, write variable t. First to define the variable t within single quote variable t. Next line, plot within parenthesis sin t comma minus 10 comma 10. The range of t minus 10 to 10 here. So you can get this graph of sin t. Next, how can you plot piecewise function in Sage? Give example. Give an example. Here, a piecewise function is this function f equal to piecewise with first right parenthesis, first bracket, next right third bracket, and next right first bracket, and within first bracket write the first piece, first write interval. This is the interval for the first piece. This minus 1 to 0. This is the closed interval, and this within this interval, the function of f is 1 plus x, comma, and next parenthesis is this. In the next parenthesis, first write the interval for this. This is the open interval 0, 1, and this is the open interval, and within this open interval the function f equal to 1 plus x square. F dot plot minus 1 to 1. So plot in the interval minus 1 to 1, this is the piecewise function. Plot this, grab the output is this. Question 6. Write Sage code to find first two derivatives ft ln log to the base e 1 plus t square and plot them along with the graph ft. Use different colors for different graphs. Question 6. Here first define t variable t ft equal to log 1 plus t square. This is the natural logarithm to the base e here, and f1 is the first derivative of f dot diff first derivative. f2 equal to f dot diff2, actually the second order derivative of the function f, and p1 is the plot ft within the range minus 5 to 5, and p2 is the plot of f2, the first derivative, and color is green, and p3 is the plot of f2, the second order derivative, and color is red. So color is red is the second order derivative, color is green is the first order derivative function, and color is blue, simply blue color, blue color plot, no color mentioned here, actually automatic choice here, blue color for the function f. So this is the beautiful graph for this. Question 6b. Differentiate fx 1 by x square with Sage using definition of derivative in 0 infinity open interval. Here variable h is the variable, single quote within single quote h, fx is the function 1 by x square, and limit first bracket within first bracket f x plus h minus fx divided by h, whole divided by h, comma h equals to 0. This means limit h tends to 0 fx plus h minus fx whole divided by h. Actually the definition of the derivative, this is the output of this, the derivative of the function 1 by x square. This is the question 6. Next question 7a. Write Sage code to evaluate the infinite integral minus infinity to infinity x square e to the power minus x square dx. Question 7. First question is integral this fx equals to x square into e to the power minus x square. Integral f comma x comma minus infinity comma infinity. Here minus small letter 0, sorry, small letter o, double small letter o, infinity gives the infinity, or simply infinity. Double small letter o gives the infinity. So integral f with respect to x minus infinity to infinity gives the output 1 by 2 square root pi. And next question b. Write the Sage code, the definite integral 0 to 1 the square root of x plus root over x square plus 1 whole divided by x plus 1 dx. Question 7b. fx equal to square root of x plus square root of 1 plus x square whole divided by x plus 1. Integral f comma x with respect to x within limit 0 comma 1. This is the output. We are unable to integrate, and so no result here. Actually here the integrate square root of x plus square root of x square plus 1 whole divided by x plus 1, and this. Question C. Write a Sage code to integrate the function sin x square plus y square with respect to x and print the result. Question 7c. Here variable within single quote y, fx equals to sin bracket start x square plus y square bracket close integral bracket within bracket f comma x. So output is this, the integration of sin x square y square with respect to x, that is dx. Next question 8 section 4. Write a program in Sage to find the area of a circle whose perimeter is p in 30 decimal places. Question 8. Here P is the float input, enter P. So when you write this in the screen, enter P and put the value of P, and P is the um, P is the perimeter. P is the perimeter. So P is the perimeter means P equal to 2 pi r. So P, capital P equal to 2 pi r. So obviously R equal to P by 2 pi. Hence area equal to pi r square, and put the value of R, and after simplification you get the P square whole divided by 4 pi. So input here, float type input is P, area is equal to P square by 4 pi dot n digits 10. Here n digits 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here total 10 digits. We get 10 digits here. Print area, we get total 10 digits here. Print area in 30 places of decimal. 30 places of decimal. So put here, here 10 digits. So here 8 places of decimal. So put here 32. So enter the value of P, say 5, P equal to 5, and this is the 30 places of decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 places of decimal. So put here, and D is equal to 32. 30 places of decimal for this. Question 8b. Write a program in Sage without using inbuilt function to print first non-Fibonacci positive integers, first 20 non-Fibonacci positive integers. So here the program for this: a equal to 0 initial value, b equal to 1 initial value for b, c equals to 0. N is the integer type output. Enter the upper range, say here n equal to 20. Here enter the upper range of n, and print first 20 non-Fibonacci positive integers, while c less than equal to n colon indentation c equal to a plus b, a equal to b, b equal to c, d equal to a plus b. For x in, so this under this while loop, this total space is here. So under this while loop, total block is this under the while loop. So you must give here indentation for while loop, and this is start for loop. This is start for loop, and under this for loop, and this is the indentation for this for loop. So total this block is under this for loop. And next if loop. For this if loop, and this only two lines under this if loop. So there is in first line indentation is here, and this second line indentation here for if loop. And next this else loop outside of if loop, but else this else inside in the for loop and also the while loop. So else break means the out of the program. So this is the program for non-Fibonacci series, and counter for count plus 1, and print count black slash t. So black slash t gives the some space between two integers. This column, two columns. So first two non-Fibonacci positive integers. Upper limit n equal to here in the given question, n equal to first 20. So put here, first run this program. For this upper range n, we put here n equal to 20, and we get the 20 first 20 non-Fibonacci positive integers. First integer is 4 non-Fibonacci positive integers, second non-Fibonacci positive integer 6, and so on. And this here the first 20 non-Fibonacci positive integers, here 14, only 14 years. So put here 30, yes. When you put n equal to 30 upper range, then you can get 20 first non-Fibonacci positive integers, and 20th non-Fibonacci positive integers is 27. Question 9. Question 9. Explain for loop construction giving an appropriate example in SageMath. Here we give an example for loop to compute the sum of integers from 1 to 100 using for loop, and print within single quote I \t sum initial value of sum equal to 0 for loop I in range first bracket within first bracket 1 comma 101. So value of I start with 1 and the final value is 100 plus 1, so final value is 100. Final value 100 and step is 1. So omit here, step is 1 comma 1. You can write comma 1 also. But if naturally we omit for this step length when step is 1, this and is sum equal to sum plus I and print equal to I \t. T means tab within the column between these two columns, and S. And this note that here indentation for loop before S and before print. So these two lines under for loop. So be careful. Note that this indentation must be given for this. And this is the print. Finally, this is the outside of the for loop. Print the total sum S of this. So I put here 100 integers, sum of integers. So first integers 1, second for this 2 plus 1 3, 3 plus 3 6. So this is the sum 6 up to 4 integers, up to 4 integers 1 2 3 4 equal to 10. 1 2 1 plus 2 plus 3 plus 4 plus 5 gives 15, and so on. 100 integers and gives the output total sum from 1 to 100 is 5050. Question 9b. Write a Sage function to check whether a number taken from the user is prime or not. So easily you can find by this predefined Sage function is underscore prime. Is the integer input, enter this number and enter here 51, and is prime false, so 51 is not prime here. But here we write a Sage program for without inbuilt function. Here a equal to integer type input, k equal to 0 for I in range 2 comma a /2 and quotient division plus 1. Plus 1 means for this I up range final value is a /2 and step is here 1. And if a modulo division I equals 0, that is this a is even, then k equal to k plus 1. And if k is less than equal to 0, print a is prime, and else print a is not prime. So run this program, enter the number. So suppose this 49. So output is this 49 is not prime. Question 9c. Find the syntax error in the following code written in Sage. Correct it. X equal to 1 while x less than equal to 10, print x star 5. So here in the first line, x equal to 1 correct, while x less than equal to. So here less than equal to this type, but in Sage code less than, then put here equal to sign. 10 and there is no colon, but put here colon this, and after while line there is a indentation print, and there is indentation x equal to x plus 1. So before print there is indentation, and before x plus 1 is also indentation, give an indentation this. So there is no indentation this. And also correct this, print x star 5 is within parenthesis, print x star 5 is within parenthesis. So correct output is this. So only you write this correction is this. So their correction this colon mark is absent in the while statement, and use indentation properly after while line. Question 9 C complete. Question 10 section 5. Give Sage code to do the following. Define matrix whose rows are given these 4 rows here, 1 2 3 4 rows here, 1 2 3 4 rows here, and display the matrix and find the row sums and column sums. Compute the determinant of matrix. Find B equal to A transpose and C equal to A minus A transpose. Test to show that the matrix B is symmetric and C is skew symmetric. So question 10 here. First A equal to the matrix, first bracket start and third bracket start, and within third bracket first row and next comma, next second row within third bracket comma, next third bracket third row, next third bracket fourth row. Here third bracket close, first bracket close. Print A equal to this. And question B, display the matrix. So A, capital A. So is the predefined function. So inbuilt function in SageMath to output of the matrix. This output of the matrix is this. So command here to display the matrix. Next, find the row sums and column sums. Let P is the row sum. P equal to the sum A capital A dot columns. So this A dot columns gives for row sums, row wise sum. So when output P, so P gives the row sums. First row is 151, second row is 230, third row is 201, and fourth row sum is 80. So for the row sum, carefully note that capital A dot columns, and Q is the column sum. So Q equal to sum capital A dot rows for column sums. So in Q, this Q gives the column sum. So first column sum is 81, second column sum is 170, third column is 70, and fourth column sum is 341. Next question 10C, compute determinant. So pre-built function, this A dot date, R is the determinant value, A dot capital A dot date. So determinant of this, output of this is determinant of this. And question 10D, find the B equal to A transpose, B equal to A dot A transpose, and C equal to A minus A transpose. Here transpose is the predefined function is A dot transpose, a predefined function in Sage. So B equal to this, so output of this, B is this, output is this. So B gives the A dot B transpose, A dot A transpose. And C is the A minus A transpose. So C gives the A minus A minus. Here question is this A minus A transpose. So here false here, put here star here. So A dash A transpose. So A minus A transpose gives this. Next question 10E, test for the symmetric and skew symmetric. Print each be symmetric, comma B dot each underscore symmetric. So each underscore symmetric is predefined function in Sage to check whether B is symmetric or not. If B is symmetric, then output is true or otherwise false. So B is symmetric is true. So this matrix B, that is A star A transpose, obviously symmetric matrix. This Aij equal to Aj. Obviously, note that this symmetric matrix. Obviously, Aij equal to Aj. And A minus A transpose is skew symmetric. So for this, we check C equals to minus C transpose. If it is false, so then it is non-skew symmetric. So it is true. C equal to C transpose is holds. So C is skew symmetric. So C is skew symmetric is true because skew symmetric Aij equal to minus Aji. So here 10 minus 10 in this position, this A1460 A4 minus A41 is minus 60, and this is so A minus A transpose obviously skew symmetric matrix. So this for check the skew symmetric matrix, we write the check we check the C equals to whether C equals to minus C transpose or not. Next question 11a. Write a Sage code to find the solution of the differential equation dy dx equal to 3x square. Write also the output. Write the Sage code to plot the solution curve corresponding to the three suitable choice of the arbitrary constants. Three suitable choice of the arbitrary constant. So, question number 11. This first x we define x equal to variable x and y equal to the function of y x. Y is the function of x. So function single quote y x. D is the differential dy dx. So differential y comma x gives the dy dx minus 3x square. In the question paper here dy dx equal to 3x square. So write this dy dx minus 3x square equal to 0. So this dy dx for deep y comma x and this minus 3x square for d for this stands for this. Then we solve d equal to 0. D equals to 0. Desolve. Desolve is the predefined Sage command to solve the differential equation for y comma y. So y equal to output is this x square plus c. Here c is the arbitrary constant. C is an arbitrary constant x cube plus c. Next question, we plot the graphs for three different values of c. So P is the graphics this for c in range 0, 25, 5. So first value of c is 0, second value is 5, third value is 10, and fourth value is 20, and this. So here we plot here fourth values of this. So this 5 is the increment, and this c final value is less than 25. Start with c equal to 0, start, and increment is 5, and last final value c less than 25, and gx equal to c x cube plus c, and p equal to p plus plot gx comma minus 5 comma 5, so p. So this is the output for 4. So you can write this 25 20, put here 20. So run this cell. So here we get 1 2 3 4 0 5 10 15. So here put only 15 put here. So first c equal to 0, c equal to 5, c equal to 10. So there are three curves in the question about the solution for three suitable curves here. So this is the question, three curves this. Next question 11b. Write Sage code to solve the following initial value homogeneous function this. Actually this question is wrong because this is the boundary condition for this, and plot the solution curve bound in a wrong question for the boundary condition is wrong here. This is the condition, so this problem. X equal to variable x, y equal to function y x, and dissolve this for deep y comma x comma 2. So actually this means 4 d2x dt square. So 4 star deep y comma x comma 2, this gives the 4 d2x dx square, plus 4 star deep y comma x, this gives the 4 dy dx, plus 17y, this 17 semicolon y. So this is also wrong, this is 17y. So this is also wrong question. 17y equals to 0. We dissolved two different functions solution, and y is the initial condition ICS. IC is the predefined functions. This equals to first value x, and for this x, this second value is y for this x, and third value is the second x. This is x0, this y0. Third, this third coordinate here is the value of x1, and this fourth coordinate is the value of pi1. So this, if we change this initial condition and then run this plot solution, and then you get the solution and this curve, and you can check for this other equation, other initial condition ICS equal to 0, -1, 0, 2. If we check this according to the given problem, and so put has here to omit this and run this program for the given problem. So there is no curve here in the plot, no curve here in the plot. Actually, if we for general interest, if we if we find the general solution of the given differential equation, so general solution of the given differential equation y equal to k2 cos 2x plus k1 sin 2x into e to the power minus 1 by 2x. Is k1 and k2 are two arbitrary constants, arbitrary independent constants, y equal to this. So general solution is this for this equation. And if we plot the general solution, particular solution for particular values of k1 and k2, we put here d for 10, and we put here d for k2. We choose here k2 for d, k2 for d, d here, k2 for k1 for d, k1 for d, and c for k1 for d and k2 for c, k2 equal to c. So the general solution is then y equal to c cos 2x plus d sin 2x into e to the power minus 1 by 2x. So first arbitrary constant d equal to 10 set. Then change the next constant c, range 0 to 25, 5. So first value of c is 0 and d equal to 10. Next graph, first graph is this, c equal to 0, d equal to 10. Second graph is c equal to 5, d equal to 10. Third graph is c equal to 10, d equal to 10, and so on. So we plot here different graphs for these particular solutions. Next question, 11b. 11b, write a Sage program to yield a numerical approximation of un for n equal to 20, where u0 equal to 1, un plus 1 equal to 1 by 1 plus un square, n belongs to natural number. Question 12. Question 12, here given u equal to 1.0. And for I in range 1, 21, because here n up to n equal to 20, so final value of I is 20 and increment is 1, u equal to 1 plus, u equal to 1 plus, 1 plus u equal to, this un called u, equal to 1 plus 1 by 1 plus u square, 1 by u square. Print u equal to, format for first second bracket put here I, and for equal to this second, for this second bracket put the value of u. So you get the output, for the u1 first term, second term, and up to u20 20th term for this. Question 12b, using inbuilt function in Sage, find the mode of the following numbers: 1 1 2 3 1 3 3 5. Find also how many times mode has occurred. So this is the giving set of numbers. This called data. Data equals to third bracket 1, 1, 2, 3, 1, 3, 5. This is given data. We write here data list within the third bracket. Mode first within first bracket data. So this mode is the predefined function in Sage. So value this mode. So here 1 number 1, integer 1 repeats here 3 times, 1, 2, 3, and number 3, integer 3 also repeats 3 times. So there are two modes, this bimodal distribution. So here uh, two modes 1 and 3. So output is this mode data equal to 1 comma 3. Print mode data. Print this mode equal to mode data. Mode data. And data dot count 1. This means in this data how many times the number 1 repeats here present here. So here one number 1 integer 1 uh, present here appears here 3 times. So data 1 appears here 3. So this command is data dot count 1. So data dot count 2 gives the number 2, the integer 2 appears here how many times is 1, and data 3 appears 3 times, data 5 appears here only 1 time. Next 12C is the wrong question here. Find the output the following two Sage codes, and this and CU questions wrong question here. For s equals to 0, here s equals to 0 for k in third bracket 1 dot 3. So 1 dot 3, but there is no colon here, so put here colon here. And indentation for this s equal to s indentation s equal to s plus k, this is equal to s plus k, and s equals to s equal to 2s, and this is not in indentation for loop, within for loop. So this is outside for loop, so this is outside for loop. So output is 22 because suppose here k equal to 1, initial value k is 1. So when this 1 dot 3 means 1 dot 3 means 1 comma k runs for 1, k equal to 1, k equal to 2, k equal to 3. So when k equal to 1, value of s equal to s plus k. Initial value of s equal to 0, so 0 plus 1. So s equal to s plus k equal to 1, and s equal to 2s. So s equal to 2 star 1 because value of s is 1. So s equals to 2. And for second loop, when k equal to 2, so s equal to s plus k gives 4, and s equal to 2s gives 8. And for third loop, for third times, k equal to 3, s equal to 8 plus 3, so 11, and s equal to 2, 11 is 22. So output s here is 22. And next, second part of this question, s equal to 0, s equal to 0 for k in third bracket 1 dot 3, third bracket 1, but there is no colon, put here colon, and here also k equal to 1 to 3, and this this s equal to s plus k is within indentation this, so put here indentation before s equals to s plus k, and this is outside for loop, so there is no indentation for this s is equal to 2s, and this is outside this. So first k equal to 1, when k equal to 1, s equal to s plus k, this s plus 0 plus 1, this is 1, and when k equal to 2, s equal to 1, previous is 1 plus k equal to 2, 3, so is equal to 3, and then k equal to 3, s equal to previous is 3, and k equal to 3, so 6. So next s is equal to 2s outside for loop, this s, so a is equal to 2, now new value of s is 6, so 2 into 6 equal to 12. So output for 6 is 12 here. Last question, question 13. Using a Sage code, create an adding machine that will keep on asking the user for numbers, add them together, and show the total after each step, terminate when user enters 0. Question 13. Create an adding machine to keep on asking the number the user for numbers, add them together, and show the total after each step, and terminate this terminate when user enters 0. A is equals to 0 while in factorial notation equal to, this means n not equal to 0. When n not equal to 0 colon, then gives indentation. So this total loop is under within a while loop, is in while loop. So so put here indentation tab here in equal to integer input integer n. So put here when n not equal to 0, put the value of n. Then s equal to s plus 1. Previous is 0, so s equal to 0 plus n is the input integer n. Print the sum s. So run this program. So put here n equal to 5. So sum equal to 5 because is 0, already previous is 0, so 0 plus 5 equal to this. Next, put enter n. Say suppose put equal to n equal to 7. So put in 7. So previous is 5, put here n equal to 7. So 5 plus 7 is 12. So output is 12. Put n equal to 0 here. So this print this. So terminate this. In the sum is 12. Previous sum is 12. So terminate the program here. Next question, Tarot 13 B. Write Sage code to solve the following polynomial equation. Solve following polynomial equation: 3 square x square plus x plus 1 minus x square minus 3x plus 2 equal to 0. Variable x equation 3 square into x square plus x plus 1 minus x square minus 3x plus 2. Print equation. So this is the equation after simplification. And s equal to solve equation comma x. Print s. This solve is the predefined function in SageMath. So polynomial equation, to solve this polynomial equation, x equals to this 1 by 8 into I into square root of 79 minus 3 by 8. If you put here dot in numerical approximation get here. So this is the x square. So you get two roots for this equation. Last question, C. Write Sage code to compute the number of zeros and number of ones present in the log 2022 factorial is. So in the previous question B, you can alternatively put f dot roots. This f dot roots. So for this, run this. This roots is this. So first root is this. For first root and second root is this. Minus 1, 8 I square root 79 minus 3 by 8, comma 1, and this comma 1. Next question is this log factorial factorial 2022. So put here n equal to 10, m equal to factorial n. Factorial n is the predefined function in SageMath to calculate the factorial n. Print factorial equals to this. So first second bracket gives the value of n, and second bracket gives the value of m. M is the value of factorial n. F equal to m dot digits. So number of digits here, here m dot digits, print the digits equal to f. Digits are this factorial 10 equal to these 3628800. So there are digits are in the list form 0088263, and the number of zeros, there are how many zeros? 2 zeros. So f dot count 0, the number of zeros, this comma s. S means this value s, variable s, count 0. Number of zeros here, number of zeros appears here, 0 appears here 2 times. So number of zeros is 2. Number of ones is 0, there is no 1 here. So number of ones is 0, means there is no 1 here. So here log 22 factorial, actually if you put this 22 factorial 2022 factorial of this. So this is the output of this 22 factorial. 2022 factorial is this. and the digits are this list of digits. Finally, number of zeros here 1060 and number of ones here 559. But a log of this factorial log of this, so factorial put here log of this factorial log of factorial this, put log of factorial this, run this, here error, so question is wrong here, is the wrong question. Thank you for watching this lecture.